Today we're going to talk about inverse trig functions, and I'm going to try to make this as easy as I can. The first part is more theoretical, and so a little, it's kind of an explanation of how inverse trig functions work, but the actual kinds of questions you're going to have are pretty basic, and I will help you through those in 1 second. Okay. So there is an important, there's quite a few extra slides you don't have today, so if you'll just be following along, we'll be good here. There's a big difference between looking at your unit circle and finding the sine of 30, which is, anybody? Cosine sine, it's 1/2, right? Everybody good? The ordered pair was square root of 3/2, comma 1/2, so the sine was cosine sine. Everybody with me? Okay, so the sine is 1/2. This is a different question. This says, where is the sine 1/2? And it actually has infinite answers. If you were to graph the sine function and the line 1/2, does everybody see that it would have infinite answers? Can you tell me 2 places that it's true on your unit circle? It's true at 30 degrees, but where else is there a sine value of 1/2? 60 degrees or pi/3, it's also positive 1/2. Does everybody see that? The y value is 1/2 in both of those places. And if I told you to name another one, you could add 360s to those, yes? Or if you were in radians, you could add 2 pi and keep coming up with names, right? All right, this notation has only one solution. This is called an inverse sine or arc sine. Now, just to clear up a little confusion from yesterday, the inverse sine is not the same as 1 sine or cosecant. This would be equal to cosecant, but this is not, okay? Inverse sine does not mean the same thing as cosecant. Some of you, a couple people on the quiz yesterday wrote something like that, but cosecant is the reciprocal, not the inverse, okay? An inverse undoes a function. Remember, it switches the x and the y. Does that sound familiar? Okay. Reciprocal is different. All right, we're going to talk about this today, this inverse, and it is also called an arc sine. Inverse sine or arc sine. I don't know how they decided there's 2 names. I feel like one is kind of old-fashioned, but I still, when I crack a math book, they always use both still. So I thought maybe one was going away, but it doesn't seem to be. All right. Now, actually on your notes sheet, at the top there, it shows a sine function graphed, right? On the top of page 24, okay? In order, first of all, is this a function? Does it pass the vertical line test? Yes. Is it a 1-to-1 function? Does it pass a horizontal line test? No. So in order for its inverse to be a function, they have to restrict the domain. Okay? Do you kind of remember we talked really briefly about this when we were doing like 1-to-1 functions? We said this is not 1-to-1, it fails the horizontal line test, but you could just talk about this branch, okay? And then it would be 1-to-1, and it would have an inverse that was a function. So that's what they're going to do here. And in order to get all of the values of the sine function represented, they're going to cut it off a little bit to the left and a little bit to the right. So they are going to cut it off from negative pi/2 to positive pi/2, because that little piece will represent all the possible values of the function. Okay, so let me see. And then what they're going to do is they're going to find the inverse of that. And if you remember, the inverse switches the x and y, so it's the reflection across the line y equals x. So it's going to go this way instead, okay? And we're going to put that on our notes. This is what the inverse function is going to look like, and it's going to flip all the x's and y's. But I think, here we go. So what you want to do on your notes here is say we're restricting it from here to here. Now, this ordered pair up here was at pi over 2, 1. And when we go to draw the inverse, it is going to be at 1 pi over 2, because we're flipping the x and the y. Is this making sense, guys? Do you remember inverses? Reverse the x and the y. All right. Then we had an ordered pair down here. Can anybody tell me what that one would be at? We went to the left pi over 2 and down 1. Is everybody okay? So it's going to be the same here, flipped. We're going to go left 1 and down negative pi over 2. All right, and the shape is actually like this. I believe it's at the bottom of your page if you want to look down there for an example, okay? All right, super important is the range of values we're allowed to consider here. All right. The range of values we can consider for outputs are only from negative pi over 2 to positive pi over 2. At the bottom of your page, it shows, somewhere do I have it on a slide? It shows this, okay? This is what you have to know and understand right here that's on your reference sheet. It's going to say your answers have to be between negative pi over 2 and positive pi over 2. It's on your reference sheet. To help you understand what that means, we're going to color a unit circle to remind us that when we're doing inverse sine, we can only look between negative pi over 2 and positive pi over 2. All right, you flip your notes sheet over. We're going to color it first here real quick, and then we'll do the cardstock one, okay? So we can look, I'm going to use red for inverse sine. That's my color coding up here. And here it lists the range. It says from negative pi over 2 to positive pi over 2. So I'm going to draw a little line going, I'm allowed to look in this quadrant. That would be 0 to pi over 2. Where is negative pi over 2, guys? Where is 0 to negative pi over 2? Quadrant what? 4. But there's a problem. Our answers down in that quadrant for an inverse sine, things like 11 pi over 6 or 7 pi over 4, those are not in this range, okay? So we're going to renumber these with negative names to help ourselves keep that straight. So if this was up pi over 6, this one is what? Negative pi over 6? Can anybody tell me what this one is then in the middle? Negative pi over 4. And the one at the bottom down here is, it was 60 degrees or pi over 3 going in the positive direction, but in the negative direction it would be negative pi over 3. And we're going to use this one at the bottom too because it's included. So we have negative pi over 2. Remember, the range had square brackets because it can include from pi over 2 all the way down to negative pi over 2. The answers to these are always in radians. We're eventually going to do this on the peach one, but you can copy it off of this one later. Okay. So this is what we're going to do for homework on this topic, is things like this. It's going to say find the arc sine square root of 3 over 2, and you're going to look for an ordered pair that has this and tell me the answer in radians. Can you look at the one we just colored? Where is there a y value that's square root of 3 over 2? Amongst the ones we colored, there was one spot that had a y value of square root of 3 over 2, and it was at, guys, what's the radians? Sorry, I should have this in a better spot, I guess. The y value, square root of 3 over 2, was here at pi over 3, yes? Okay. Sorry, I went by it. Okay. Can you answer this? Where is the sine negative 1? So where is there a negative 1 here? Good job. Negative pi over 2. Because remember, you can't call it 3 pi over 2 anymore. That's why we renumbered it. The answers have to fall between positive pi over 2 and negative pi over 2. All right. I skipped this question on purpose. Is there ever a y value of negative 2 pi? No. I don't know why they do so many of these, but if we were talking about a decimal, this would be negative 6.28, because that's twice pi. When you think about the sine graph, the regular old sine graph, does it ever hit negative 6.28? Okay. This is not possible. For some reason they ask a lot of not possible questions on these, but all right. We're going to keep going with the other ones and see if we can make a little sense of this. The next one we need to talk about is cosine. Look at my cosine graph up here. Do we want to restrict it from negative pi over 2 to positive pi over 2? Will it pass the horizontal line test if we do that? You don't have, it's on the front side of your notes, but on 24A, guys, will it pass the horizontal line test if I restrict it from negative pi over 2 to positive pi over 2? No. So we have to restrict this one a little differently. In order to get all of the values from 1 to negative 1, we're going to restrict this one from 0 to pi. So go to your paper, and we're going to this time on 24A show that we are restricting it from here to here. So can anybody tell me the values at either end there? The top would be 0, 1. And the bottom value over here would be pi negative 1. So when we go to draw the inverse function, what is that going to look like? Where instead of 0, 1, we're going to have what? 1, 0. And instead of pi negative 1, we're going to graph negative 1 pi. And it's going to look like this. Now, some teachers and books would make you memorize those graphs. I am not going to worry about the graphs. I just want to worry about you to be able to find the right answers using the unit circle. Again, for inverse cosine, we're talking from 0 to pi. And on the reference sheet at the bottom, it says right here, 0 to pi. Because this is what you're going to be given. You're eventually not going to get to use a colored sheet. You're just going to have to know that your answers have to be between 0 and pi. So on your colored unit circle, can you pick a different color for arc cosine? And you want to color from 0 around to pi this time. So I'm going to do blue, and I'm going to do it this way. My arc cosine answers can be anywhere between 0 and pi in quadrants 1 and 2. Do I need to renumber anything this time? No, we already have all of our numbers from 0 to pi. Yay. All right, I'm going to go back here and do a couple examples of what you might have on your homework. Okay, so look for this value. Do you remember what this means? What angle has a cosine, which means an x value, that looks like that? Now, there are two angles on our unit circle, but we want the one that we just colored in. So in quadrant 1 or 2, where is there that value? Yep, 5 pi over 6 sounds right to me. Everybody okay? Let's go to this last one over here. Where is the cosine negative 1/2? Is that 2 pi over 3, guys? Okay. All right, guess what this middle one is? I know it's not on our unit circle. You can actually find values that aren't on the unit circle. You could do second cosine on your calculator if it was a decimal. But just a minute, can the cosine ever hit 2.5? Whoops, that's not a cosine graph, sorry. What is the maximum and minimum value when we have a cosine? Goes from -1 to 1, right? I know this is an inverse cosine, but it's still answering where is the cosine 2.5, and it doesn't ever happen. So that would be not possible. All right. And the last one is tangent. Some of you did a great job yesterday. Some of you need to retake that section, but the tangent graph goes through the origin and has asymptotes at -pi over 2 and pi over 2. So what is a normal way we could restrict that, guys? Isn't it passing the horizontal line test right there? If we just look at that little chunk. So on your notes, we're going to say we're going to keep this restriction here and here and just talk about that little piece, okay? And those asymptotes were at -pi over 2 and pi over 2. And when we reverse the x and y, those will become +pi over 2 up here and -pi over 2 down here. And it's still going to go through 0, 0. All right, and it was positive and getting, I don't want to draw this wrong. I think I know how to draw it, but let me look at the picture. Okay. So it's bending this way just a little. All right, again, I am not going to make you draw these or memorize the drawing. What you do have to know is how to use the restricted domain. And on the reference sheet, it looks like this. Is that the same as another one? The same domain, or same range, I mean. It's almost the same as what? The sine. It's almost the same range as the sine. The difference is tangent is undefined at negative pi over 2 and pi over 2. So therefore, we don't have to include those values. So if you go to your unit circle, my suggestion is you don't do a third color. You just use the same one as sine. Okay? But finding tangent is very tricky. Do you remember how to find tangent? How do you find tangent on your unit circle? Yes, we had to put y over x, and so I'm going to have you, at least on your notes, I'd rather you didn't do it on your reference sheet, your little peach sheet. I don't care if you do, because you're not going to get to use that anyway. You're going to have to use the regular reference sheet. But so for now, if it will help you, but you have to think about how to get this every time. So starting up here, 1 over 0 would be, so the tangent up here is undefined. You might want to write that on your notes. Okay, what is the tangent right here? Do you remember when you put the y over the x, square root of 3 over 1 is? Square root of 3? Everybody okay? I can do it over here if you need me to. It's square root of 3 over 2 divided by 1/2, which is times 2 over 1, which becomes square root of 3 over 1, or just square root of 3. All right, what about here? Square root of 2 over square root of 2? Just 1. What about this guy down here? This would be 1 over square root of 3. Do you remember how we rationalized that? Became square root of 3 over 3. What about here? Is it undefined or something else? When you put 0 over 1, you get 0. What happens when you're down here? It's the same as which one? Instead of going 30 degrees or pi over 6 up this way, you're going this way. And it's got a -1, so it's going to be negative square root of 3 over 3. What about this one? -1, and this one will be negative square root of 3. And over here, it actually doesn't include this value at all, so you can't have this one, but it would be undefined, the tangent would be. Okay. All right, so let's answer a few questions here. I'm going to talk about this. If I don't have a colored unit circle to use, I have to think and know the tangent is in these two quadrants. Okay, everybody paying attention here? I'm looking for an ordered pair that would give me this. That's messy. So my thinking is I had to do this so that 1 over square root of 3 became square root of 3 over 3. Okay, and it's supposed to be negative. Well, in this quadrant, I'm going down, so I would be looking for this ordered pair with my non-colored plain old unit circle. That ordered pair would occur at 11 pi over 6. Is that the right name? Anybody have a plain old unit circle out? At 11 pi over 6. But what am I going to call that instead? I can't call it 11 pi over 6. I have to call it, instead of going this way, I went this way. So it is called negative pi over 6. All right. For a tangent to be -1, I'm looking for a square root of 2 over 2 and a negative square root of 2 over 2, because that's the only way I'll get a 1, and it's got to have a negative. It's got to be down here. So that's 7 pi over 4. But what do we call that when we renumber our unit circle? Negative pi over 4. Okay? So that was my thinking to get me to the non-numbered unit circle, non-colored one. All right, let's go to these questions on the back of your worksheet. These are underneath your colored unit circle. Find them. All right, how fast can we answer these? Where is the sign -1/2? Now remember, inverse sine or arc sine is defined in purple on my graph right down here. It's in quadrants 1 or 4. So it would be negative in quadrant 4. I'm looking for an ordered pair that has a -1/2 in the sine spot. Something and then -1/2. I don't care what the something is. -1/2 in the sine spot. What is that called? -π/6. I can't call it 11π/6 because I have to have a value between π/2 and -π/2. All right, number 2 right below it. Cosine, where is the cosine 4? Just picture a regular old cosine graph. Does it ever go to 4, guys? I usually write not possible. You can write does not exist. Okay. Arc tangent. That's another way of saying where is the tangent? 0. Okay. When it's y over x, we're looking for this ordered pair. Or we wrote the notes here. The tangent is 0 at how many radians? We're looking for an answer in radians. Still 0, right? 0 radians. Number 4, arc sine of square root of 3 over 2. Where is the sine? Square root of 3 over 2. So we're looking for a square root of 3 over 2 back here. Riley, where's that happening? Good job. Okay, cosine square root of 2 over 2. So square root of 2 over 2 in the x spot. Where is that happening, Ben? Yep, got to answer in radians. Good job. All right, this is a tricky one, except we kind of cheated and wrote it on there. Normally you wouldn't know. Anybody know what this is telling you? Is the y or the x got a square root of 3 over, if you made it square root of 3 over 3, it had to be 1 over square root of 3. Do you remember that? So if we hadn't written these, we'd have to be thinking about how we got this one. But that's the one we did get. So it was at, what did we have to call that spot? -π/6. All right. Where do we look for a cosine value of -1/2? Do we look down there in quadrant 4? No, remember cosine is colored differently. Cosine can be in quadrants 1 or 2 because you won't find a -1/2 x value down there. Cosine is x. Where does that occur? Kaylee? Good job. Sorry, I just did 4, 5, 9, and 10. I'll go back and do the ones I skipped. I didn't realize the numbering was. Number 6, where's the tangent -1? That would have to be where the x and y are the same. And one of them is negative. Anybody figure that one out? -π/4 down there. Where is the sine? Negative square root of 3 over 2. Sine is y value. Antoine, can you find that one? Where's the y value at negative square root of 3 over 2? Yep. Yep. So it's right here. And you have to tell me what angle. Okay, the answer to an inverse or arc sine or cosine or tangent question is the angle in radians. So it should be negative pi over 3. How we doing on that one, guys? Okay. Is there a negative 2 on this unit circle anywhere in the y spot? No, it can't ever be greater than 1 or less than negative 1, so this is not possible. Okay, did we just do all of the top section there? Okay, I'm going to go to this next section, and we'll do a little more of this tomorrow, but a lot of times an inverse function undoes a function, but that is not 100% of the time, okay? I'm going to skip 11 for the moment. I want to talk about 12. This says find the cosine at pi over 2. Okay? So looking at it as a normal unit circle, go to pi over 2. The x value is what? 0. You remember you work functions inside out. So now it says where is the cosine 0? Yeah, it's pi over 2. Those just, that undid itself, inverse cosine, cosine undo each other. Okay, let's look at 14 while we're in this section here. This is not going to undo each other because we have two completely different functions, right? But we start inside, go to pi over 6, and tell me the x value at pi over 6, and you get square root of 3 over 2. Okay, so the cosine is, now it is asking you the inverse sine of square root of 3 over 2, because we found that the cosine was square root of 3 over 2, and we substituted that in here. So it's saying, where is the sine square root of 3 over 2? Well, that means we're looking for a square root of 3 over 2 in the y, because it's a sine now. And that happens up here at pi over 3. Good job. So inside out. All right, let's look at 13. Tangent 3 pi over 2. What is the tangent at 3 pi over 2? Well, 3 pi over 2 was down here at 270. Remember, you'd have a normal unit circle that wasn't renumbered here. And the tangent is undefined. Okay. Inverse tangent. Well, I think there's no solution. Do you see here it says they undo each other if you're between negative pi over 2 and pi over 2, but not including pi over 2? You can't undo an undefined, so this is not possible. That's just gross. I won't ask you that, I promise. Let's talk about number 11 real quick. Number 11 is actually a kind of question where you would have to draw a picture, but the inverse sine of negative 3 pi over 4 is some angle in quadrant what? First of all, can a sine be 3/4? Think about that. Opposite over hypotenuse. I know it's not, can't be on our unit circle, but if you picture a sine graph, its maximum is 1, right? Can it hit 0.75 then along the way somewhere? Yes. Okay. If we were at 0.75 here, could we undo it? Yes, we could. It would go back to whatever the angle was before. Okay. So this is just negative 3/4. I will make more sense of that tomorrow when we draw some things. I'm not going to worry about that one today. It's not on your homework, I promise. Okay. Actually, none of these are, so I'm going to save the rest of these for tomorrow. What I want you to work on is worksheet 25A. I'm going to stop, maybe I won't stop the recording. I don't think I have it on here though. All right, I will stop the recording. But all you're doing, here, someone read me, what's number 1 say? I'll just do a few. Like this, okay? So we're going to use our colored unit circle, and cosine is x, so we're finding this value, and that occurs at pi over 3. Anybody pick one on that side? Elena Finley, can you read me one? I don't care if it's number 2 or number 17 or number 13 or number 8 says what?
Inverse sine minus pi over 2. I mean, not pi over 2. Square root of 2 over 2.
Okay. So where is there a sine value that's called negative square root of 2 over 2? Would be in quadrant 4, but you can't call it, what, 7 pi over 4 is its usual name? We're going to call it negative pi over 4. How about a tangent? Anybody find a tangent one on there? Maddie, can you find a tangent one for me anywhere? What does 11 say? Okay. So in my mind, when we did y over x, we had square root of 3 over 1. I'm thinking that was, is it pi over 3, guys? Is that right? Is that what we wrote next to pi over 3? Okay, we square root of 3. Ben, can you pick one? Anyone? Sine, cosine, tangent, anyone but number 1, 8, or 11. You don't have to do it even. Just tell me the problem. And what does number 4 say? Does it say arc cosine, or it does say cosine negative 1? Okay, and then what? Oh, inside here, like that? Okay. Where's the cosine negative 1? Emma, can you find a spot where the cosine is negative 1? That means the x is negative 1. It's only one spot. Is it colored the right color for cosine? Okay. That is pi. Good job. All right. Is that enough? Okay. I'm going to let you work on finishing worksheet 25, side A. Let me know if you get stuck on one. It's possible. I don't remember for sure if there's a impossible one or not.